Hello everyone, welcome to today's session. So I'm Dilan Sachinda. I'm a senior software engineer at WSO2. I've been working with Ballerina for around 2.5 years now. So today we will discuss what GraphQL is, what Apache Kafka and Docker is, and how Ballerina has an amazing support for these different kind of technologies. So today we will do a bit of an introduction, then we will discuss what GraphQL is, then we will talk about what GraphQL, how GraphQL is supported by Ballerina, and then about Apache Kafka, and then how Ballerina has support to interact with Apache Kafka servers. Then we will talk about what Docker is and how Ballerina supports working with Docker artifacts, and then we will move on to the main part of our session, that is the demonstration. So let's start. So what is Ballerina? So Ballerina is a modern open source cloud native programming language. So this was specifically designed to build microservices and distributed systems. And also Ballerina has built-in support for creating REST APIs, GraphQL APIs, interacting with message brokers such as Apache Kafka, RabbitMQ, and also Ballerina supports deploying all the services that are created in the cloud. So in this session, we will mainly focus on the demonstration, which is how a Ballerina GraphQL API can be developed and how it can be integrated with the Apache Kafka server and how that created API can be deployed on Docker. So we will first try to understand what GraphQL is. So GraphQL is an open source data query and manipulation language. So basically we can say a query language for APIs, and GraphQL allows the clients to request only the data that they need. So let's see in the sample. Here the user has requested the profile of John and he has only asked for the ID, the name and the age. So the GraphQL API has responded exactly the data that the user has asked. So even though the GraphQL API has data of John's profile like address, date of birth, the API has not sent those. So in the, in this, the users don't need to do any server-side processing to like filter out the response data, and they can just basically ask what they need and they can directly use that. So here we will discuss about what GraphQL with Ballerina is. So Ballerina comes with built-in support for creating GraphQL APIs. So we don't need any external or third-party libraries. And also Ballerina supports both the code first and schema first approaches in GraphQL. So in GraphQL we have something called a schema. So this schema defines what a GraphQL API is. So here in the left side, let me take the as a pointer. So in the right side, you can see a schema. So this schema says this GraphQL API has a query which is named as greeting, and it will return a string. So in the left side, you can see the respective Ballerina code for the GraphQL API. Here the GraphQL service is running on port 9090, and we can see a query. So queries are uh, used as resource functions in Ballerina. So this we have a query of name greeting, which returns a string, and in this case, this API returns hello world. So this is called a schema first, where we have the schema and we write the code that is that is matched to the schema. So in the other way, in the code first approach, we first write this code and then we generate the schema from this code. So Ballerina supports both these approaches, where you can basically write the code and generate the schema, or you can basically get a schema from somewhere else and generate the code related to that. And also Ballerina supports all the query, mutations and subscription techniques in GraphQL. So query is like something like you use to get information from the API. Mutations are things that you use to update data in the GraphQL API, like update some value, delete some value. Subscription is also used to get data from the API, but in subscriptions, unlike queries, subscriptions are long lasting and maintain active connection with the GraphQL server. So basically we can say query is like a get request in REST, and mutations are like post, delete and put request. uh, okay, so then now let's see what Apache Kafka is. So we can say in few sentences, Kafka is a system that lets you to publish and subscribe to streams of data. And here Kafka provides a messaging system that allows actually applications to send and receive data in real time. And also Kafka has the ability to store and process streaming data. So Kafka can store and process large volumes of data in real time, making this ideal for use cases like real-time analytics, creating high throughput fault tolerant applications. So in Ballerina, we have a great support for working with Apache Kafka servers. So Ballerina has a library called Ballerina Kafka. So it has a set of APIs to interact with the server. So Ballerina has an API called producer, consumer, and listener. So basically, when describing what Kafka is, you can see. Let me take the pen. Mm, So we have a server. So we can say this is the Kafka server. So the server has something called topics. So I'm first going to describe what Apache Kafka is. So these topics we can call them T1, T2, and T3. Okay. So these topics are the ones that store the messages. So these topics as M1, M2, like that. So a message belongs to a topic. So then we have something called a producer. So from the name we can understand what it does is produce messages. So producer can produce messages to any of the topics. So he can send message 1 to topic 1. He can send a message 4 to topic 2, like that. So there can be any amount of producers, and any producer can produce to any topic. And also then we have something called consumers. So from the name we can understand what this does is consume messages. So these consumers can subscribe to topics. So once a consumer has subscribed, the consumer can read the messages in the respective topic. So consumers can subscribe to any number of topics. So once then now this consumer has subscribed to T2 and T3. So when a producer produces a message to these topics, the consumer will receive it. And also there can be any amount of consumers. Okay, so in Ballerina, we have API for this producer. We call it Kafka producer. And also we have API for the consumer. And also we have something called a listener. So the listener is also a consumer. But the difference is for a consumer, we what we do is we pull the data from the server. So when we need some data, we call the API poll, and we receive the data in the server. But for the listener, we don't need to do explicit pulling. Whenever there is a new value in the topic, this listener will receive the value. We don't need to explicitly pull. We will implicitly get the value. So okay, okay. So here you can see the code, Ballerina code for a Kafka listener. So this listener is connects to a Kafka server in the default URL. So the default URL is localhost and port 9992, and it's listening to the order topic. So whenever there are new orders in the order topic, this function will automatically receive them as a array. So here we do a little bit of processing where we check whether the order is valid and we log the value. Okay, so now let's see what Docker is. So Docker is a platform for building and running and managing applications. So Docker uses containers, something called containers. They are lightweight, standalone, and executable packages of software, and they include everything which is needed to run an application, such as code, the runtime, the system tools, and also the libraries. So a developer can use Docker to create a development environment that is identical to the production environment. Also, this will help to reduce errors, and also it will make it easier to deploy applications. Okay, Docker with Ballerina. So Ballerina has built-in support for creating Docker artifacts. So we have a tool called C2C. C2C means code to cloud. So it is a compiler extension packed with Ballerina. So in C2C, what happens is when we build the Ballerina program, the compiler extension will get activated, and it will read the code, and it will derive the required values to generate the Docker artifacts, and it will generate the related Docker artifacts. So the C2C extension currently has support to generate Docker and Kubernetes artifacts. So to do this, what we basically need to do is add a simple parameter to our build running command. So this is the command bell build dash dash cloud equal docker. So if you want to generate K8's artifacts, what you need to do is you say bell build dash dash cloud equal K8s. Okay, so let's move to our demonstration. So in this demonstration, what we will do it in several parts. So we will first try to see how to write a GraphQL service. Then we will see how to use the Kafka consumer and producer and how to integrate it with this GraphQL service. Then we will try to generate a Docker image and run it in Docker and see how that works. So before that, we need some prerequisites. So you need to have Ballerina Swan like latest version installed, and we can use the VS Code to code. So Ballerina has a good support for coding in VS Code, and you can install the VS Code extension. And you need to have a Kafka cluster running, that is needed for the second part, and also you need to have Docker running, that is needed for the third part. Okay, so this will be our demonstration. uh, so we will have a GraphQL API. So, and we have something called publisher and subscriber. Note that this is not related to the Kafka producer or consumer. So these are something we call publisher and subscriber. So we are going to make a news alert system. So this publisher will publish news alerts, and these subscribers will try to receive these news alerts. So the GraphQL API will get these news alerts, and GraphQL API will put those news alert to a Kafka topic, and subscribers will get these uh, news alerts from this Kafka topic via this GraphQL API. So we have a data store to store the information about the subscribers and publishers. So to make this demonstration simple, we won't use any database. We will just use in-memory tables, which is a concept in Ballerina. Okay, so let's start our demonstration. Okay, so let's start. So let's create a Ballerina project. So my Ballerina version should be latest on the update 8. So let's create a new project. It's a news alert demo. Okay, now let's open it with latest VS Code. Okay, so we have a main file created by the tool. So we don't need that. Instead, we'll create a new file service.bal. Okay. So before starting, let me first show you what our final output should be. Um, Wait a minute. Okay, so this is our target. So we are going to create a GraphQL service endpoint news, which is running on port 9090, and we will have some queries This query is to get users in the system, and this is to get the publishers in the system. So they are returning a user array and a publisher array. And then we have a mutation. We have three mutations actually. This mutation will publish a news update. So that means the user will send a the publisher will send a news update, and the GraphQL API will process this news update and send this to a Kafka server. So here in this produce news, we have a Kafka producer, and he will send this to the Kafka server. Then we will have two mutations to register the register user and a register publisher. So these will not do any interaction with this Kafka server. This will just basically put this in the in-memory table. So then we have a subscription. So a user can subscribe to a particular agency. So we have something called agency in this. So a publisher sends news updates to an agency related to an agency. So a user can subscribe to an agency. Then the user will receive receive any latest news occurring in that particular agency. So these are our final uh, functions. So let's try and write this. Okay, so first let's try to create a GraphQL service. So we will run, the endpoint will be news, and we will start it on 1990. Then what we have to do is let's first create the function users. So this function, this query is to get the existing, get details about the existing users in the system. So a query is written as resource function. So it written as get. So query get users, and we need to return. What should we return? We need to return a list of users. Okay. So we are getting some error. Oh, it's still loading. So for now let's return empty array. Okay. So the system doesn't know the type user, so we haven't defined this type, so we need to define this. Okay, so we have a type user. So this is created as a closed record. There are two types of records. One is a closed record, there is an open one. So open record is shown as this. So these records can have any values, string a, like that. uh, The difference is these open records can have any more fields that are not defined here. So a closed record can only strictly have this defined field, but the open records can have any more additional fields. Okay, so I'll just let me just copy the user values. That's much better, I think. So user should have a ID. So yeah, here user have ID, and user, let's put the name and the age for the user. So user has ID, name, and age. Okay, so this is what we'll return. For now, we will return not empty array, since we need to view this. What should we do? Let's create like hard code a value. ID should be, let's say, 1, and then name. Let's see if Copilot suggests. Okay, yeah, it's 30. Okay. Mm, so let's try and visualize it in our diagram. So we have a support for diagrams in Ballerina. Okay, so this shows our new API. So we have a query as users, which returns a user array. So this user record has ID, name, age. Okay. So here also you can like edit the record here also. So you can add new fields here. You can add any types. say decimal, we can say some value. We can, so when we add update the diagram, this record will also get updated. Okay, and also we can add mutations queries using this as well, diagram. Okay, so now let's run this. So it's running. While it's running, let's we can save some time by creating another query called publishers. So we need to, this query is to get the list of publishers. So here what we need to return is list of publisher. So then the system doesn't know what a publisher is, so it should give an error. And now let's create the record publisher, just like the user record. So publisher also should have ID, so we can identify him specifically. And then publisher should have string name, string area. Let's add area. These are like not needed. And also an agency. So the agency is used to publish news. So a news, when we publish a news update to the system, and the news belongs to an agency, and a user will subscribe to this agency, so that the user will only receive the particular news that belong to this agency. So we need to create an agency. So we can make it string as well, but better if we can make it an enum, so that we can so that we can like limit the number of agencies. Num agency, let's say, okay, Copilot is suggesting this, so let's say, okay, we have a new agency, BBC agency, CNN agency, and Fox agency. Okay, so now this is giving an error because the types are different. Okay, Copilot is really helpful here. Okay, name, so name, publisher name is, let's say, so let's say Jack, area UK. Okay, okay, so this, okay, the system is running, so we can work with this. um, so there are several clients that we can use to work with the GraphQL APIs. So we have this built-in client. We can run it by this try it button. So we enter the path, and okay, this client is started. And also we have a web-based client. So web-based client, we can to enable the web-based client, let's stop the service. So what we need to do is we need to add some configuration to the service, our GraphQL service. So when we are adding service config, and we need to say graphical is enabled. Okay, sorry. So we call it a graphical client. So we need to provide this configuration to make it enabled. Okay, so now let's run our system project again. Okay, now it's running. Okay, so our system API is running, and okay, the graphical client is ready at this URL. So let's go to that URL. Okay, Okay, there are some. Okay, we have several queries that I already tried. Let's try a new one. Okay, so since we have a query, we need to make query. Okay, sorry, query. Our query is users. So let's say users. I need users, and I need to say what I need from these users. So this will return a user array. So user array has details like ID, name, age. But I don't need all of these values. So I only need ID and the name. So I'll ask for that. Okay, so since I asked for ID and name, it will only return these two. If I ask for age, it will return age only. Just like that, I can say I need the details of publishers, and publisher doesn't have this value. So let's say I need the agency. I'll get okay, nice. So from this client, we can also view the GraphQL schema like this. So we have the different records, what publisher, everything. We have two queries, users, publishers, like that. We can view the schema as well. The schema is automatically generated when we run this upper service. So that is happening inside Ballerina GraphQL module. Okay, so let's stop our running service. Okay, so for the rest of the session, I won't use this graphical client. So I'll remove those configuration. I'm going to use something called what is Altair GraphQL client. Okay, so it will start up. It's the same as the our web-based client. Mm, okay, so until it starts, let's write our mutation. So we wrote our queries. Now what we need to write is the mutations. So as I showed earlier, we had three mutations. We have the mutation to add the add the publisher, then add the user, and then we have a mutation to publish news. So in Ballerina, mutations are written in as remote functions. So let's write the mutation to add the user. So not actually add the user, we call it register user. So let's say remote function register user. So here, okay, we have a function to register user. So in order to register user, we need some details from the user, actually the GraphQL client. So we add input parameters. So we need the type as new user, since we are going to add a new user, register a new user. So the system doesn't know the type of this new user, and then we return the client, the registered user, return user. Okay, so let's create a record. Okay, so the new user will also have these values. So but he won't have the ID, because ID is something we add to the system. So we get the name and the age of a new user from the client, and we register that user, and we return the client. We return the client with the values of these. So for that, let's create a user. We need to create a user. Uh, okay. So here, since this user has some values from this new user, we can just include those values here. So for that, we will use type inclusion. Let's say new user. So that way, if new user has some values, so that way the user record will have these values that the new user also has. So this new user is created as a open record. So in that case, if this new user, as I said earlier, open records can have additional fields. So since this has additional fields, it will be little confusing because user type will also get those fields. So to avoid that, let's make this closed record. Okay. So now the user record contains ID, name, and age. So we need to create an ID. ID should be a unique value. So you need to, let's use the UUID library in Ballerina. So let's create a unique value. Okay. So other two fields we can directly get from this. So we can use the spread operator. New user. That way the user record will have ID and the two values, name and age, from this new user record. So now we need to store this in our system. So to store this, let's create tables. So there's a concept called tables in Ballerina. So table can have a list of values. So the table will have a type user, and table needs to have an ID, sorry, a key. So a key is used to identify the values in our table, to uniquely identify the values. So key we need to make the key as ID, since ID is the unique value that we create. So we say user table. Okay. So now we have an error. Let's see. Field ID used in this must be a read-only field. That's because if it is not read-only, it can change in the runtime. So that will be confusing since we use the ID to uniquely identify the value. So let's make it read-only. Okay. Now the error should go. So now we have the user and we put this in the user table. Put user, and we need to return this value to the user as well. Okay. So we have an error. Okay, it's still loading. Just like this, we need to create the publisher mutation as well. So register. Oh, sorry. Please ignore this slowness because I'm recording in the same time, so it takes a huge toll on my machine. So when we publish register, when we register a publisher, we need to get the new publisher value from the user, and need to return a publisher. So let's create a publisher, and let's create a publisher record as well. A new publisher record. Okay, so publisher will also have these three, and ID is something we create, so we don't need the ID. Also, let's use type inclusion here. Okay, so here let's use the spread operator. Okay, and we need a publisher table as well. Publisher, call this publisher table, and now we return publisher. Okay. Okay, now all should be good. So we have two mutations and two queries, and let's write our last mutation, that is remote function publish. So what publish does is it publishes a news record. So what should we return? So we have to define types. Mm, so user will send a news update to the system, and we return a news record. Okay. So we need to generate with these records. So this is getting a bit ugly. So we have the service and underneath it we have the types. So it's better we can create a new file and add the types there. So let's copy these types. That way I think it's much more readable. Okay. So we need to create the news update record and news record. Awesome. Okay. Okay, we have an error. Okay, we need to create the record ID read only, and we have two new types: news update and news record. So what should the values be here? So for the news update, let's have so this is what the user sends. So user will send a headline, and user will send the content. Then okay, then the user will send a publisher ID. So from this, so actually news update is not sent by the user, it's sent by the publisher. So since this is sent by a publisher, this should have a publisher ID to identify which publisher sent this. So from this publisher ID, we can identify this news which this news update belongs to. Like I mean, since a publisher has a uh, agency, we can from the publisher ID we can understand that this belongs to a particular agency. So if publisher A sends who is from this BBC agency sends this, we can send this value to the related agency in the in our system. So okay, so now let's add the news record as well. So new for the news record also we need to have ID. Let's make it read only string ID, and then we will have all the values from the news update. Okay. Also for these types, we can like document these types as well. So so that like anyone can understand what this type is trying to show. So okay, ChatGPT Copilot is really helpful. New user for a new user. Let's say this represents the information of a user that can be registered. And this Copilot, seriously? Okay, so Copilot is not being helpful here. I'm copying these values from my already did implementation. Okay, so this new user has the values name of the user and the age of the user, and what this record represents is the information of a user that can be registered. Awesome. Okay, like that we can add documentations to all of these, but to save time, I won't do it. You can do it by yourself. Okay, so here we are now the user has published a news update. So since we are not integrating this with the Kafka server at the moment, we cannot publish this to the Kafka server. Instead, let's create a array which contains news records. News record array. Okay. So now from the user's values, let's create a news record. News record. ChatGPT, please. Okay, awesome. Okay, so we created a news record and we need to push this to news records. Okay, now let's return news record to the user as well. It's giving an error. Oh, invalid usage of mapping constructor expression. Spread field news update may have already specified keys. So here is, since the news update is not closed, it may have already specified keys as well. Okay, let's save it. Let's save it here as well. Okay, let's format our code as well. I think it's already okay. Okay, now let's run our system. So we now have three mutations and two queries. Okay, Altair is started as well. Okay, okay, it's already it already has some things that I did earlier. So I think we can use those as well. So I have mutation to register user Lisa, register user John. Then I have mutation to register publisher Jack, register publisher Rachel, and also I have mutation to publish news update. So please ignore this. Let's say Ballerina is awesome. Awesome. Okay, it's running. We are getting some warnings. Let's ignore them for now. Okay, so first we will do a query. So it's okay. Our query should be we need, let's say, give me users. So I need the ID, I need the name, I need the age. Okay, let's run the query. Okay, we didn't update our queries to return the saved values. So let's do that quickly. So what we need is, instead of hard coding, since we have now have the values, what we need is we need the user table. Okay, so it should give an error. So it's saying, okay, I can't return the table since what I'm going to return is a user array. So what should we do? We can do to array. Also, here also, what we need to do is publish a table to array. So if you can use Copilot, it's really helpful. You can see like it's showing so many suggestions, which are some are wrong, but most of them are correct. So it saves a huge time. Okay, let's run this again. Okay, so until it's running, we can do much. We can do anything in the client until it's started. Okay, so I will explain what we need to do next. So for the next one, we need to write a subscription. So in subscription, a user connects to the system with specifying agency, and we need to send the news updates for that particular agency. Okay, so it's started. Okay, first let me show you. We can see the schema here. Okay, docs. Okay, so let me show you. So we added the doc here to which record? Okay, we added the doc to the new user record. Let's see. Uh, Sorry, sign the query. Okay, new user. Oh, okay, nice. So when we add the docs, these are added to the schema as well. Okay, let's close this. So okay, now we have a query. Let's send the query. Okay, we have an empty array. That's fine because our tables don't have any values now. So let's register a user. Okay, user Lisa is registered. Okay, John is also registered. Now let's view the users. Awesome, nice. So we have Lisa and John. We have unique IDs here as well. So like that, we can register Jack as a publisher and Rachel as a publisher, and then we can view the publishers. Let's we need agency. Okay. Okay. So Jack is registered with the agency Fox with the unique ID as well. Rachel. Okay. Now we have the publish mutation. So in this mutation, what we do is, so this is just a name that I give to the query. I say this mutation is published, and I need to provide the input parameters. So my input parameter is news update, which contains headline Ballerina is awesome, and the content Ballerina has great support to create APIs, and I need to say a publisher ID. So I already have two publishers registered with the system. So here I say Jack. So since I need to send this news to the Fox agency, I specify Jack's ID. Okay, let's publish. Okay, so that news is published. So we don't have a way to view these news updates yet. And then now we need to let's do something like this. Let's say I give an invalid ID. Let's see what happens. Okay, we have that as well. But this doesn't make sense, no? So if there's a if the so this ID belongs to an non-existing publisher, but our system sends a successful response here. So we need to handle that. So when an non-existing publisher sends a news update, we need to send an error. So what we need to do is, if this, oh sorry, this is not the function here. If this, we don't add curly braces. If news update dot publisher ID, oh, sorry, if publisher table, we need to check in the publisher table whether this exists. So has key this publisher ID. If it has key, there's no problem. So if it doesn't have this key, we need to return an error. Not found, let's say not found. That's much easier. Okay, so now we return an error. Now, if this publisher exists in the system, there's no problem. Okay, let's save it. And now we have one compiler. Incompatible types expected this. Okay, we only expect this to return, but now there's a possibility of returning error as well. So let's say we may return new record or we may return error. Okay, okay. Now let's write the subscription function. So subscriptions are also resource functions. So these are used because these are used to get values. So remote function subscribe. Let's say news. So um, so in order for a user to subscribe to some get the news, he needs to say that specific agency. Like the users need to say that I need news from this agency. So let's say agency. Okay, ignore this one. And what we need to return is we don't return news record. Why is that? Because in subscriptions, so since this user subscribes, user doesn't ask for a one news record. Instead, what the user asks is he needs all the latest news records that are published to this particular agency. So instead of this, what we return the user is stream of news record. So that way, when there are any new news records, we return uh, each of them. Okay, so let's return uh, news records to stream. There's also something wrong. Why is that? So in this one returns all the news records in our system. But what we need is we need to filter out the news that belong to this agency. So for that, what we need to do is, okay, ChatGPT is showing me something. Let's accept that. Okay, let's see what it does. Okay, so Okay, so what this does is we filter our news records by the publish ID. So that is wrong, no? Oh, is that correct? So we don't have something called agency.publish ID. What we need to do is here, um, so particular news record has a publish ID, and from that publish ID we can get that publisher's agency. So from the publisher table, okay, now I think what this suggests is correct. Okay, so from the publisher table, instead of getting it like this, get, okay, we get the value, and now this is returning a, so this expects a stream of news record, but what we are returning is a news record array. So let's do to stream. Okay. So now what we do is we do a filter. So news records dot filter. For each news record in the news records, we get the publisher value from the publisher table, publisher's details, and then from the publisher detail we get the agency. And if that agency matches the user sent agency, we select that, and we get those all the filtered values as a array, and then we convert it to string. Cool. Okay. So let's run our system again. So there is also a problem where hmm, okay, there's no problem. Sorry. Okay, so we have written all of our functions related to our API. So our next step will be to integrate this with the Kafka server. So for that, we don't do any integrations with this user details. They will be kept same as this in memory. What we need to do is we need to update this publish function to interact with the Kafka server to produce these news records to the Kafka server. And then we need to update this subscribe function to get the values from the Kafka server. Okay, so our system is started. Let's use the client. Okay, so now we don't have any values in the system because it's we started it from the beginning. So memory is clear now. So let's register Lisa and John and Jack, Rachel, and now let's update, publish and update. Let's, okay, we have an invalid ID. Let's try and send that. Okay, we get an error, publisher not found. Okay, that makes sense, right? Okay, now we need to get this, let's send the news to Fox agency. Okay, you use the ID of Jack, who is the publisher of Fox agency, and we publish that news. Okay, that news is published. Let's publish another news. Let's say GraphQL is awesome. GraphQL is awesome. And we send that news as well. Okay, now let's send the news to the other agency, which is CNN. Okay, so let's say Kafka is awesome. Create Kafka applications. Okay, okay, now we have three news records. Two is for Fox and one for CNN. So let's subscribe to this. So our subscription is the query starts as subscription, and then we give a name. We there's no need to give a name as well, I think. And our subscription is to news, and we need to provide a agency. So we need to provide an agency, and this user we don't need to provide this. When integrating with Kafka, we will provide a user as well. Now we don't need. So Okay, this docs is not updated, I think. Okay, so it's giving an error. Okay, why? I don't know. Let's write it from the beginning. Mm, stop this as well. Okay, our subscription is new name subs subscribe to, let's say, news instead of CNN. Okay, our subscription is news, and our input parameters are agency. What was the agency? Fox, no? Okay, Fox, and what we need is we don't need everything. We need headline and the content. Okay, okay. Now we have two values. Let's clear this and let's ask. Okay, now we have two values. We have the one we have the two values that we sent to Fox. Ballerina is awesome and GraphQL is also awesome. Okay, then let's say we need values from CNN. So okay, subscribe. Okay, we have the value Kafka is awesome. If we subscribe to BBC, we won't get anything. See, we don't get anything. Okay, so this is our um, basic GraphQL API. Okay, we have an error logged as well. What's that error? Publisher not found. Okay, so since we returned error here, where we sent an invalid ID, we get the log of that error as well. Okay, so we have completed the first phase of our implementation where we did the GraphQL API. So in the next phase, we will do the Kafka implementation. Okay. Okay. So as I said earlier, before doing our Kafka integration, we need to have a Kafka cluster running. So you can download the executable here, or instead uh, I can use this as well, but I think it's better if we run this Kafka server in a Docker container. So that way it's easy to stop and restart the service, and we don't need to provide any configurations manually. So I already have a Docker compose file written to start that Kafka server in locally in my machine. So I will share it with you as well. So instead of this, I will use that. Okay. Okay, so this is the Docker file. We have something called zookeeper and broker. We have two containers that is running. So zookeeper is a concept in Kafka. We don't need to go into the details of that. It's something which is controls these brokers. There are some things called brokers. Basically, this is what we call as Kafka server. The brokers store the Kafka topics, so there can be multiple brokers. But in this case, we only have one broker, so it's running on port 9090. So you don't need to worry about these configurations. So only thing we need to know is that this is running on localhost and port is 9092. Okay, so let's start the Kafka server. For that we use docker compose -f compose up. Let's make it down like to make sure whether if it was already running or not. So okay, so it is running. So while it is starting, let's start our coding. So up until now, what we did was we pushed the new record to our in-memory array. So instead of that, now what we need to do is we need to produce this value to our Kafka topic. So as I said earlier, there are something called Kafka topics. So for this, what we will do is, since the news update is associated with the specific agency, for the topic we will use the agency. So what that means is, So in the Kafka broker, even there is a news update, we will create a topic with this agency name. So we have three agencies. So Kafka broker will have three topics. Kafka server will have three topics. Topic BBC, topic CNN, topic Fox. So when a news update comes to topic BBC, we will produce that news update to the topic Fox, like that. So to do this thing, what we need is a Kafka producer. So let's create a Kafka producer. Let's add Kafka. So now we can import Kafka. So now VS Code will automatically import Kafka. And what we need is a producer. So let's say producer. So this producer is producing news. So we need to say news producer check new. So for a producer, we need to provide the URL. So please ignore if there are any background noises. Dog is barking. Okay, so here we need to provide this the Kafka server URL. So it's running on the default URL. So we can say default URL. And okay, so we can go to this implementation of producer and we can see what we need to provide. So we can provide we need to definitely provide the server URL, and we can also provide the producer configurations as well. There are so many configurations. Since we are running on the default configurations, we don't need to worry about these. You can read this description when if you need to know more about the values. Okay, so okay, now we created the producer. Now what we need to do is produce the message. Okay, let's say. So this check statement is to return if there are any errors. So let's remove this. I'll explain. So here the producer, when the producer is initialized, producer can return an error. So here when we do the new, there may be a chance to return an error. So since we are not catching that error here, we need to do a check. What this check does is if there's an error, the check statement will return that error. So same as that, here when we need to do is news producer. Okay, it's news producers. We have API called send. So send API accepts a producer record. So let me go to the record. So send API accepts a producer record. So producer record can contain the topic. It must definitely contain a topic, so that we can know where to send this to. Then it can have a key. Optionally, it can have a key. We don't need worry about that. And we should provide a value. So value is our news record. So here the topic should be the agency name. Value should be our news record. We don't need to worry about the timestamp and partition as well. Okay. So here need to provide a record. Let's say topic. Topic should be agency. So how do we find the agency? So we have the news update. News update has the publish ID. So from that publish ID, we can get the agency. Okay, so what we need to do is from publisher table, we get news record dot publisher ID, and then we say we need the agency. Okay, then we need to provide the value. Value should be the news record. Okay. So here, okay. So here we did the check because the news record will what returns it when it is in. If there is a connection error or something, it can return an error as well. So since we are not catching that error, what we need to do is we need to return that error. So this check will take care of that. Okay, so now we don't need this push, and we don't need the array as well. Okay, nice. Okay, so now we have an error here. So in the subscription, this will be a little bit complex, and since we don't have much time as well, what I will do is I will not write it by scratch. Instead, I will copy it from the implementation I did already, and then I will describe it. I think that will be much better. Okay. Anyway, our publishing mutation is complete. So we create a producer and we send. Okay, there is a little problem. So whenever a new publisher, new news update comes, what we do is we create a producer. So this is something redundant because for each news update, creating a new publisher doesn't make sense. So instead of that, we can create the publisher in the module level, or I think it's better if we create in this service inside the service. Okay, so we create this inside the service. Think okay, so okay, now we have the news producer. This is inside the service, we need to call it self.newsProducer. Okay, right. Okay, so for each news update, we produce that. And to subscribe, I will copy the value code. Okay, so I copied the code. So here, um, I have a service. I have created a service class called news and also another class called stream generate, news stream generate. Okay, let's see what this is and what we will do. So here, instead of returning a news record stream, what we are going to return is a news. So up until now, for all these methods, what we returned was a record. See, everywhere we return a record user, publisher, and also here also we returned a stream of records, news record. But now what we are going to trying to return is a service, stream of service. So in GraphQL, in Ballerina GraphQL, the output object types can be of two types. One is the record type, the other one is a service type. So a record type can be used if an object, output object does not have fields where these fields may contain input arguments or maybe they do not need any calculations or processing to resolve the field value. So instead, so in these cases we can use record. So for every where we didn't need that processing or anything, so we just use records. But for this case, what we need is we need to do some processing. So processing in the sense we need to poll the Kafka server for records values. So to do some things like this, we cannot use the record. Instead, we use the service class. Okay, so let me start. I will write this and you may not understand what I did, but in the end, I think you will be able to understand. So now we don't need this filtering or anything. We don't need this filtering because now we are pushing the values to the agency topics in Kafka server. So we don't need to filter. We can just pull the records from that specific topic. Okay. So here, okay, let's remove this is not needed. Okay. So when we return this news stream, the news service class says functions to get the ID, get the headline, get the publisher. So when we do this, this headline content. So we say we subscribe to news and we need headline and content. So these functions are the things that get created. Ah, okay, I deleted the content. Sorry. Okay, sorry. These functions are the ones that gets called. Okay. So and then we have something called news stream generator. So in order to create a stream, we use a generator here. So these stream generators are built functions which contains an isolated init method and also a isolated function next. This it must contain a isolated function next. So what happens is when we generate the stream and return, the client side will call the next function. So when this next function is called, here we have to define what should we return. So here what we return is we return a news value. So this news value is a service class. Sorry, this one. So in the stream generator, what happens is when this next function is called, we return a news value. So this news value is the service class. It contains the values to, it contains the features to get the ID, headline, and content. So here, okay, we need to import the log module. Okay, so let me write the code. Yeah. Okay, so we need to have, mm, we create a news stream first. News stream generator, news stream generator. Oh, sorry. Stream generates here generator check new. Since we had a check, we need to add error also to the return type. So the inputs would be consumer group and agency. So okay, so in the init function of the stream generator, we initialize the Kafka consumer. So for each subscription, so whenever a subscription happens, what we return is a stream of news. So here in the generator, what we initialize a consumer. So each news for each news function sorry, so for each news function invocation, we return a new stream generator. So we create a new stream generator. So here we initialize a Kafka consumer. So whenever a user says that he need to subscribe, we create a Kafka consumer here. So the Kafka consumer needs some configurations. So it definitely needs a consumer group. So this consumer group is used to uniquely identify the consumer in the Kafka broker level. So different consumers, I mean, multiple consumers can have the same group ID. In that case, these set of consumers will belong to the same group, and only one consumer among those will get the uh, news updates. So since we need all of our consumers to get the news updates, we cannot hard code the consumer group ID. We need to provide a unique value. So for that, let's use the user ID of the user. So we say string user ID. We need the user ID. So since our user ID is something generated by us here, the unique value, we can use that as the consumer group. And this offset reset, we can use the inbuilt configuration. Um, yeah, this one. And max pull records, when we are pulling, we this Kafka server will return all of the records in the topic, like all of the new records in the topic. But here we need only one at a time. So for each next in function invocation, we only need to provide one record at a time. So therefore we say the max polling records per one poll is one. Then we create the consumer here. Then in the next function, so this is invoked by the GraphQL client. So what we do is, for each run, we do a poll payload. So in poll payload, what happens is this consumer will talk to the Kafka server and ask for any new values. If there's a new value, we map it to this news record. So this consumer is built to return all the new values in the Kafka topic. Therefore, we return an array. But here, since we only ask for one, this array will contain only one value. So there can be errors as well when pulling the values, maybe connection errors, something like that. So if that is the case, we return from this function and print the error. If there are no records, what we need to do is we need to continue polling the server. So there may be cases for like for 1 hour, the server there may be no any news updates related to an agency. So in that case, we should wait until like we should continue polling the server for new values. So here this 20 is the timeout. So this poll payload will wait for 20 seconds until the Kafka server will return a value. If until 20 second goes up, there is no return values from the Kafka server, this will return empty array. So if there's an empty array, what we do is we continue the loop. So if there are values, uh, here is just a print statement, we can remove this. If there is a new value, what we do is we return that value. Okay, so here let's go to our implementation. We need to provide the user ID and the agency. Okay, so we have a stream generator. Now what we need to do is we need to create a stream of news. Let's say stream news stream. So we initialize it by providing our generator. Then we return news stream. Okay. Okay, we have some errors. What the? Okay. Oh, sorry. So this is giving an error. What is saying? Invalid stream constructor accepted a subtype of object public isolated function next, but found new string generator. Okay, but expected public isolated function. Okay. Oh, okay. So I haven't made this function isolated. Okay. Now it's isolated. Let's see what any other errors gives. Okay. Now we have error here. Okay. Cannot use check in an object field initialization of an object with. Okay. So it says we cannot use check. Also, there's another error. Okay. Let's first attend to the first error. Okay. We cannot initialize it since there's a check. What we can do is we can use the init method. Init function. We can write the init function. We can say this is the final value. We say self dot news producer equal. Okay, so we initialize this. Okay, so we need to add the return error statement, error or nil. So it takes a little bit of time for this compile extension to show any values or update. It's because I'm recording in the background, so that recording app takes a huge amount of performance. Okay, now we have one error. What that's the invalid non-isolated initialization expression in an isolated function. So we are trying to initialize news service class. So it says invalid. So since this function is invalid, isolated, let's make this isolated as well. This initialization function. Let's try if that solves our issue. Okay. looks like it's solved. Okay, so basically what we do is we create a stream generator, we provide the related values, and then we create a stream of news service. Then we return the stream of news service. So whenever user subscribes to this news, uh, the API will return a stream of news service. So then the client will invoke these values when he needs these values. So it will return these values. Okay, now let's try and run it. Let's see if it works. Okay, before that, let's see our Kafka server started. So we have a little bit of an error. Okay, I think I know what there is. I haven't provided the configuration files needed for this. Uh, I will copy that and restart this. Okay, I copied the values. So let's try and start the Kafka server again. Hopefully it should start now. While it's starting, let's do something. So since these are also types that we use in the implementation, let's move them to our types util file. Okay, that will improve the readability, I think. Okay, so now we have some errors. What are those? Okay, don't have the import of Kafka here and the log import, I think. Okay, okay, so that this file is working. Okay, types file is done. So we don't, okay, this is unused, so it is giving an error. Okay, now this is also fine. And this also we can move to, let's say, datastores.val. So in the future, if we want to change these data stores to something like MySQL databases or something, we can do it in this. Okay, and then since in this file we do on the GraphQL stuff, we can move our Kafka stuff to something else. Okay, so here we can write a function produce news update, and it returns error or nil. And here we can we can produce the value, let it format. Okay, so this gets getting really slow. My machine is okay. Looks like our Kafka server is up and running. Okay, okay. Zookeeper and broker both are running. So I have an error here. Okay, so we don't know what news producer is. So we need to have the news producer here. So we have Kafka. Okay, so in this case, we need to pass this Kafka producer to this function. Instead of that, I think since this is because this Kafka producer is created in the service level. Instead of that, let's move him to Kafka utils. So he should be there, right? So let's say Kafka producer and let's say he, okay, let's initialize him here, and then we can get rid of the function. Okay, so I had to pause my recording because my dog started barking. Okay, so we moved the producer initialization to here. So now this is module level. So it's given error undefined module. Let's do a quick fix. Let's import this module. Okay, so now what we need is the news record. So let's get this as a function input parameter. This is news record. Okay, so now when this function is invoked with the news record, this function will try to produce this news record to the Kafka server. If there's an error, it will return the error. If there's no error, it will return nil. Okay, so now we can remove this import as well, and we need to call the function. What did we name that function? Produce news, right? Produce news update. Okay, all right. So now this should give an error. It says variable assignment is required. That is because we are returning error. So we need to, if we need to catch that error, we need to assign that error to a variable. Otherwise, we need to return that error. Okay. Okay, now I think all good. We can go ahead. Let's try and run. Okay, so our Kafka server is also running. Mm, okay, so you need to remove it as well. Okay, it's taking a little bit of time to run. Okay, so it's giving a bunch of warnings as well. We will attend to them in a little while. Okay, now so our API is running. So, so since this started from scratch, there won't be any new values here. Okay, so we need to register our user, John, then Jack, then Rachel, and now we need to publish a news update, no? Okay, let's publish a news update to Fox. Okay, we say we publish. Okay, we publish Kafka is awesome to Fox. All right. Okay, so news update is published. Now we need to subscribe to that agency, and also we need to now our subscription function is updated. We need to provide user ID as well. So let's say what is user ID. Okay, user ID is let's say you Lisa. So Lisa is the one subscribing. Okay, so it's giving an unknown error because this I think this schema is not updated yet. I think it's because of that. Okay, let's send a request. Okay. Mm, so oh sorry, I'm subscribing to BBC. Where did I publish the news? I can't remember. I think Jack's one. Yeah, I used Jack's. It's used Fox, no? Okay, let's stop the subscription. Or else we can just yeah. So I'm subscribed. Okay, let's stop the subscription and let's subscribe to Fox using John's ID. Okay. Okay, okay. Now I'm getting news. So I get the news. Kafka is awesome. Ballerina has great support to create. Oh, okay. Let's publish another one. Ballerina is awesome. Okay, I got another news. Okay, I get Ballerina is awesome. Let's do GraphQL is awesome. Nice. I get another one. Now what we should do is let's publish something to CNN. Okay, I'm publishing this. And I say the present is awesome. Okay, I don't get that because I'm only subscribed to Fox. Okay, let's stop it. Nice. So our implementation is working. So we getting bunch of warnings. That's because there may be cases where there are no news available in BBC. Okay, so it's working as expected. Now what we need to do is we can try and fix these warnings as well. Okay, I stopped our running application. Mm, okay, so let's try and fix these errors. Okay, so what the error is, so it's saying in line number 6, since this method is not isolated, so resource this method is not isolated, it will not be concurrently invoked. So for that, let's say we need to make this function isolated explicitly. So here what we say is this function is definitely isolated. In a function like this, if the function can be made isolated, in the other words, if this function can be concurrently invoked, the compiler, the Ballerina runtime will concurrently invoke it. Like that means if this can be concurrently invoked, this will be isolated, even if we don't say it is isolated. But if we say this is isolated, this should be definitely isolated. So this should definitely be able to invoke concurrently. But in our implementation, we have done something wrong. Therefore, it cannot be invoked concurrently. So we are trying to access user table. So let's make it isolated as well. Okay, let's make this one as well. So it's the same two things, no? Okay. Okay, so our table is isolated and now we get a bunch of errors. So what is this error? Okay, so isolated variable cannot be accessed outside of a lock statement. So let's lock this. Oh, let's try and okay, yeah, let's lock this, and then what we need is we can return a read-only value. In that case, we can guarantee that the value won't be changed. So it says we are trying to transfer a value from a log statement. So if we make this read only, then we can guarantee that what we return here will stay the same. So make it read only. Then we need to return a read only value. So we say we we do clone read only. Nice. We should do the same for this function, and we lock it there, and we do clone read only. Okay, okay, like that. And we need to make all the functions isolated. So we don't need this isolated keyword if it can be concurrently invoked. since we need to make sure this should be isolated, let's add it everywhere. Then we will get a bunch of errors and then we will fix it. Okay, so here also what we need to do is we need to lock. Okay, so it's saying this user, we have also we cannot put the user value to user table. So in that case, what we can do is we can uh, make the user record read only. So not the user record. Um, okay, so yeah. So we can make it read only. Mm, okay, so there's some errors. Okay, this error we will attend to later. Okay, so okay, now we can put the value in there. Now let's lock this one also. Okay, publisher is giving the same error. Do the same thing. Okay, so now there's another error. Publisher table. Okay, so publisher table is isolated. Do the error here. Okay. And also we have another error. Produce news. Okay, so what it's the error? Okay, the function, it says this function is not isolated also. So let's make it also isolated, and we need to we need to lock this one since we are trying to access the isolated variable. Okay, now it's giving another error. Okay, news record. Okay, so since the news record is not read only, okay, better I think if we can make the news record read only as well. Okay, so okay, news record is read only. Now our errors are gone. Well, okay, now we have error. We also do the lock here. Hopefully it should be gone. And also we had some errors in the types.bell line 53. Okay, let's make these also isolated. That way we can make sure this service function is also service class is also isolated. Done. Okay, we don't have any compiler errors. And yeah, okay, now since we are sure that this can be invoked isolated, we can remove this isolated keyword as well. Instead, let's keep it as it is. Okay, so now what we have done is we have created a GraphQL API, and we have integrated the Kafka server to the GraphQL using our Ballerina Kafka clients. And also we have made this isolated, and our code is, I think, readable. Okay, and also I need to describe something about Kafka here. So here we are using the uh, Kafka consumer, Ballerina Kafka consumer. Here, what this does is this pulls the values from the Kafka server. So as I said in the presentation here, We have three set of APIs. We have used the producer and consumer in our implementation. There's also something called a listener. As I explained, what this does is the consumer is used to pull the records from the Kafka server. But if we have a Kafka listener, we don't need to pull. The records will be automatically received to our Ballerina applications. So in this use case, we don't have a way to use that. Instead, we use the consumer. Okay, so I think second part of our demonstration is complete now. Okay, let's try and run it to make sure. Hopefully the warning should also be gone. And our next step is to run this service in Docker. So for now this is running locally. Let's try and build the Docker artifacts and try to deploy it in a Docker container. Okay, so it's running now and we don't have any compiler warnings. Let's register Lisa. Okay, we only need to register Lisa and Jack, and let's use Jack's ID to publish a news update. Okay, let's say Ballerina is awesome. Okay, we didn't publish it yet. Yes, let's use you. We have an error. I didn't see that. What is that error? Maybe we before the service start we sent the request. Okay, we don't get the error for that. I think. Okay, it's registering. I think I always sent the request before the service started. Okay, so I use Lisa's ID and I will try to subscribe to Jack's news agency. Okay, next is Fox. Okay, I'll try to subscribe to Fox. Okay, I'll clear. So I got this all three messages again because my user ID is my user is different. So this user will get all the messages there. So let me clear and let's publish a news. Oh, sorry, news update. Oh, I clicked the subscribe again. Okay, I think it messed up. Yeah, since I clicked the subscription again, an, another consumer with the same group ID is created, and I don't think he will get the news values because there are two consumers with the same group ID, and therefore he will not get the second one will not get value. So therefore, let's create a second user. So let's use that his ID to subscribe to Fox. Okay, now he should get the values. Okay, let's publish news again. Okay, he's getting it again. Okay, nice. Okay, so in the next session, what we'll do is we will try to deploy our service in Docker. Okay, so for this, let's go. Okay, so as I said, we only have to do a simple thing. We instead of doing the bell just plain bell build, what we do is bell build dash dash cloud equal Docker. Okay, so let's do that. Dash dash cloud equal Docker. Nice. So, okay, there's the new Ballerina version available as well. I guess you can use that. It's always better to use the latest Ballerina version. So now since we have added this parameter, the C2C extension will be activated and it will go through our code and it will generate the necessary Ballerina artifacts, necessary Docker artifacts. Okay, so it's building the Docker image. So this is where the outputs of our build command is. So we can see like several Docker uh, not Docker dependencies. These are our application dependencies, and the Docker file is created here as well. So this file is to create the artifact. Okay, so the Docker artifacts are created, and we have a suggestion to use this. We can use this command. So what this command will do is this will our generated Docker artifact is named tagged as this. So what this will do is this will start our Docker container in this port. Actually, this not in this port. It will expose this port so that we can communicate with that port locally. But the issue here is since we have a Kafka container running in the separately and in our Kafka utils in our producer we call the Kafka URL as localhost. Since both these two are running in the Docker as Docker containers, we cannot now call it as localhost. So to mitigate that, what we can do is instead of running it like this, we can say run this container on the host network. So let's say network equal host. That way we will be able to call this container as localhost as well. So then we don't need to expose these ports because this runs in the same host network. Okay, so docker run dash dash network host. We say new salad demo latest. Nice. Okay, so our container is running. So can do a docker ps and see. Okay, so it's up 7 seconds ago. Nice. Okay, we have 3 containers running now. Okay, let's try and use the client. Okay, okay, Lisa got registered. Let's okay, Jack is registered. Let's use Jack's ID and let's add a news update. Let's say Docker is awesome. Okay, we before publishing that news update, let's use the ID and power. Okay, okay, we subscribed. Okay, we got the news. Let's clear that and let's send this news. Docker is awesome. Okay, we got the news. Docker is awesome. Nice. So now our Docker container is also running. So now our GraphQL API is also running on Docker, and our Kafka service is also running on Docker, and the GraphQL client is running on localhost, so it is able to talk to the Docker containers. Okay, so we are getting these warnings as well because the subscriber is still subscribed to that agency. Okay, so we'll stop the Docker container and see. Okay, our GraphQL API is now stopped. So that's how we create Docker containers. And as same like this, we have the way to create Kubernetes K8s artifacts as well. We only need to do is provide the parameter K8s here. This will basically do the same thing like earlier. It will create the related K8s artifacts. So in order to run this K, this in a, run these K8s artifacts, you need a Kubernetes cluster running. So to try it locally, you can install Minikube and try. So I won't demonstrate that here. So okay, so it's generating the artifacts. Okay, so okay, so I'll go to the end of our session. Okay, so if you want to learn more about GraphQL APIs, you can follow this learn page. Uh, and also, if you want to learn how to learn more about Docker, how to generate Docker artifacts, or K-Test artifacts, you can follow this guide. So this guide has end-to-end example as well, as I remember. So you can follow it. And also there are so many examples provided by the Ballerina developers that you can follow. So it has basic language concepts and also the examples for many network libraries. So gRPC, GraphQL, REST, Kafka, everything. And also there are a list of YouTube tutorials as well. Say YouTube Ballerina Programming Language. Okay, so you can subscribe to this channel as well. So there are many playlists where Ballerina developers explain what Ballerina is. So you can follow these also. And also you can ask any question that you have in our Discord server or our WSO2 Stack Overflow collective. And also you can follow our Twitter handle. And you can see our Ballerina source code in Ballerina platform in GitHub. And yeah, I think that's it. If you have any questions, you can contact uh, this email or you can anytime raise this in the Ballerina Discord server. Okay, thank you.